I'm Thorsten. I run a company called Natural Motion. I want to talk about how we combine creativity and optimization. We're a games company. We make games for iPhone and Android. Our biggest game is called CSR Racing. It's got about 120 million users, so about 2% of the world's population have played it. But we didn't start that way. We actually started as a technology company, and we had this idea that we could do animation in games and in movies completely differently. We thought, what if you don't have to hand animate characters? What if you actually let the character animate itself? So we thought, how hard could that be? What you do is you simulate a character and you add to that little muscles and you add to that essentially a brain that makes it animate itself. And I want to show you what that first result looked like. It looked like this. Not very good, basically. This was after 8 hours of a simulation running, and we had been hoping that there'd be a character walking on a screen and that would solve all of our problems. And the problem was we didn't iterate and we didn't optimize. This was the first iteration of this kind of approach, and it didn't really work. So what we learned was we needed to find a way to essentially let these creatures learn themselves how to do this task. And the task is walking, because that's what we wanted to animate. So we developed an algorithm, it's called a genetic algorithm, that uses artificial evolution to essentially iterate and optimize itself to get to the point where we wanted to get to. And that looked like this. So this is generation 0 of this optimization process. And as you can see, the character is not that good at walking yet. But now after a few generations of optimization, artificial evolution, you can see that the character takes the first steps. And after a few more generations, it takes a few more steps still. And eventually we managed to get this to work. So eventually after 20 generations, this character actually walked without falling over. And that was a big breakthrough for us, and was the first time we realized that if we combine a new idea with an iterative optimization approach, we can have something that is completely different to anything else. And the reason we were so excited by this is because we managed to eventually scale this up to full human bodies and have them interact with each other. And things happened that we didn't expect. And I want to show you a very simple example of this. Eventually, we got all of this to work in real time and is now powering the characters of games like Grand Theft Auto, for example. So if you've played GTA 5, all the character interactions are driven by this technology. But the cool thing is, surprising things happen. And here's a very simple video of something that we've captured a while back, where we put two of our characters too closely to each other on the screen, and we found out that they started squabbling. Now, this is not something that we actually put into the characters. They have a full balancing behavior, as we call it. They have full interactive ways of moving their arms, and they're trying to protect their personal space. But as a result, it ended up with two characters squabbling. And this video actually went on for another 20 minutes. They just basically didn't stop. So I'm going to show you a short bit. But that is the power of optimization with creativity. And we were really excited by this. And eventually we thought, well, this is all working. Can we use this ourselves? So we started making games ourselves. Rather than just creating technology, we started to make games for iPhone. And our first game was a game called Backbreaker, which used our technology to create an American football experience where all the tackles, all the interactions were realistic. So we wrote the game, we tested it internally, and eventually we showed it to an audience. And we actually tested it with real users. And this is what the first user experience looked like. So there was a problem, basically. All the stuff that we just created, we realized when we actually put it into the hands of the users, they didn't really get on with it. And in particular, there was a problem on iPhone and on Android, because a lot of people are not gamers, yet we wanted them to enjoy the game. So what we had to do was iterate and change the difficulty level at the beginning, and we changed it to this. So as you can now see, miraculously, anytime an opposing player gets close to you, they just dive past and they just miss you. And you think you've done something right because you can see your character kind of stepping sideways, but actually you haven't done anything, because what's happening is that we make sure that the character, the opponent, dives past you. And as a result of that, we've created the most incompetent football team ever to grace a video game. But what it allowed us to do after this iteration is it allowed the user to have this experience here, which is touchdown, I've made it, and maybe I am a gamer, and maybe this is a game for me. And that was really important to us, and we started doing that with user testing. So for our next game, we did the same thing, and that was CSR Racing. We user tested the game. It's a very simple racing game. It's just a drag race, and all you have to do is shift at more or less the appropriate times. And in the first game, we make that really easy for you. We give you a BMW, and we set you up against a very slow hatchback. It is essentially unlosable. We tested it with users in our offices, and eventually they were all quite happy with it. When we then put the game out into the wild and we got real data at large scale, we found that the unlosable first race was lost by 36% of the people. So that was a problem, and that showed us the power of big data and the power of iterating with big data. And this is a really obvious one, but there are a lot more subtle things that you can find out once your product is out in the wild. And I want to show you a quick example of this. This is what's called the funnel of the game, the first few steps, the first few minutes. And what we saw was, actually, we had a drop-off here. You can see there was a race here, and a lot of people lost that race. And that was because, again, that race was too difficult. About 4% more than we expected were dropping off. So we made it easier, and that's the dotted line here. And that meant, as a result, that 4% more players ended up playing the game. So we add up all of these small iterations on top of each other. You end up with very big movements in terms of player retention in the game. So that's what we've been doing over the last few games. But what's next? So our next game is called Dawn of Titans. Here's a screenshot taken on an iPhone. And with this game, we have huge battles. We have about 7,000 people in real time battling each other. But with this game, we wanted to take iteration one step further. We didn't just want to wait for real data coming in. We actually started to simulate what players would be like even before the game was released. So what we're now doing is we run simulations of 10,000 virtual players with different play patterns, and we try to predict how they're going to spend money in the game or the in-game currency. So here's one of the graphs of such a simulation run. And what you can see here is the different lines of the different player types, how many times they play in a day, how much money they're spending, etc. And then the lines show how much money they end up with in the game, how much in-game currency. And you can see that it diverges quite a bit. And that allowed us, we were hoping, to predict what real players would be doing. So when we eventually soft launched the game, which has just recently happened, and we're getting the first test data in from real people, this is what that looks like. And it's actually quite close. So that for us is the next step. And the really exciting thing about this is, if you look at, there's a very good match overall, but there are a couple of kinks here that we didn't expect. And those are actually points where the economy of the game is broken, and we have since fixed that. So we're now able to take this one step further and iterate on things that we can even simulate before the game is released. But at the end of the day, it all starts with creativity, and that's really important to us. And I just wanted to show one of the characters that we're most proud of in the company, called Clumsy Ninja, which is a game that we released about a year and a half ago. This was all our creative output, and it started with that. It's something that we were really proud of, and then when we had the game out, we were able to iterate, make it better and better and better. And if you can have that combination of creativity and optimization, we think it's possible to create absolutely awesome products. So that's my short summary. Thank you very much.